So what is ROS, and why is it so prevalent in the robotics community? ROS stands for Robot Operating System, and it was released in 2007 as a means to create a collaborative software framework for robotics development. You see, robots are hard enough as it is to build, but roboticists always ran into the issues of having to write all their operating code from scratch, generally in some type of embedded systems C-type language. For example, it could take weeks just to code a blinking indicator light. Creating the firmware controllers, managing the serial communications between your microcontroller and the main computer, and then actually creating the high-level software node to dictate when the light blinks a certain way. Not to mention all the debugging and visualization systems you would have to create so you could actually make sure your code, sensors, and actuators are working as intended. That is a lot of coding just to make a light blink. Thus, ROS was born as an open source project which comes with tons of built-in tools, as well as packages created by other developers to help minimize the amount of software development time needed to get your robot up and running. ROS 2 came around to fill in some of the gaps the original ROS 1 failed to be able to fill. ROS 1 excelled in applications in controlled areas, such as robotic arms. But since then, the robotics application space has grown tremendously, with applications such as limbed outdoor terrain capable mobile robots, drone swarms, and so much more. ROS 2 creates a new decentralized style of robotics development. It caters towards features such as multi-operating system support, allowing security configurations for node data streams, as well as a reliable, independent communication structure that doesn't fall apart if there are disruptions in the network. It also allows for cross-version support, so you can still work with systems that were previously developed with ROS 1. So why should you learn ROS? Bottom line, it saves you as a robotics developer time by giving you an optimized framework with many other developers contributed to help you get up and running quickly and scale your robotic systems. ROS is used in a variety of applications, from research and development, robotic arms, humanoid robots, self-driving cars, and so much more. Not to mention the multiple programming language libraries developed for it, with C++ and Python officially supported, as well as community-driven libraries in Java, JavaScript, and Lua, and so much more. ROS continues to be developed and improved by the vast open source robotics community, all from which you and your robots can benefit from. So let's go ahead and jump into ROS 2 so you can see exactly what it has to offer.